2D problems. Yawn. Show me the 3D. Not so fast. You need to get your 2D working just as equally as you do your 3D. G'day, I'm Bruce from Barking.BIM, and I help people get the most out of their BIM platform, in this case, Archicad. We're in the middle of creating a fully custom parametric door in GDL, making use of all the tricks available to you in the Archicad environment. Follow along with me in this episode to see how I deal with the sort of logic problems you will encounter all the time. Stuff that you think will be so simple often leaves you scratching your head wondering how you're going to solve this particular problem in a neat and logically elegant way. That's a good coding adjective, elegant. If you stick around and watch to the end, you will pick up some useful info. I have my frame outline. My frame outline will be what you see in the distance beyond the cut. We won't be using the cut fill properties. So I will put my frame outline before all of that. This is what we're drawing here. And how will it look? If we have just an opening like this, my frame outline will be like that. If my frame extends out to there, my opening will also extend out to there. So my frame outline needs to come out to here, which is pointing out a few other things that we need to fix. One is I've got nothing to snap to at the back of this frame. I've got nothing to snap to at the edge of this frame. And my wall hole is not responding at the moment to a thicker frame. So when this comes up to here, the wall hole should be out at this line here. I should point out that these lines, this frame fill we're going to be drawing, is different than the lines drawn for a wall if the door is not cutting the base of the wall. Right, what do I mean by that? Our door unusually has the frame running underneath the door because we're going for a kind of a sci-fi feel, sort of an airlock sort of feel to the door, which is not typical in your architectural projects. So that's why we will be drawing a frame underneath it, because you'll be seeing that in the projection below the cut line. However, doors can also not be cutting right down to the base of the wall. So if this was a normal door, for example this, that the frame didn't continue across the base of the door and it was sitting higher up in the wall, you would expect to see wall contour lines below this door. And you can do that. So we've got this 100 sitting 100 higher than the base of the wall. And we've got our default wall contours here. Now this comes with a door object. I've not done any scripting with this. And if I put on full, I get cut contours on my wall and I get projected contours front and back. So I can change it to just the side ones, in which case the front and back ones disappear, and I can have the length ones, like so. We'll talk further about that when we come to do our wall hole. So the frame. What do we need for that? We need our frame plan pen, GS Pen 2D, and we just need a background fill. First of all, let's just draw our outline. And this is where our logic starts to fall apart a little bit. Because what we need to do is we need to draw our frame outline responding to these logic tests here, where we set our frame width based on our cut planes, and then we'll draw this dashed line if it's a narrower frame. But we also want our projected frame outline to respond to this same test. But if we put this down in here, it will be on the wrong side of the wall. So how do we deal with this? Because what I want is frame outline starting at minus a divided by 2. Then we'll go plus a divided by 2. All right, it's in place. You can see that it's drawn it above my polys, which I don't want. I want it below. So let's put this down the bottom. Pen will be our 2D pen. And fill will say frame background fill. Now that's not been defined yet. So we will define an empty fill and call it. Now let's see what happens. What happens if I put this back up the top? Right. So it was drawing on top because it didn't have a fill. And now when I draw it first, everything else draws on top of it. But I want this side. Just turn off the fill for now, just until we resolve the size of it. Oops. I want this side to come out to here, which means I need to set this frame width before I do any of this work, which means that this if statement where I draw my line needs to change. So how am I going to deal with this? This is my logic statement. Frame step left is greater than or equal to cut planes info 1. So that's what I'm doing, testing down here. If frame step left is greater than or equal to cut plane height, then I want my GS frame width to be GS frame width times 2. So I can say, right, let's explain this logic. My frame width left, which is this side here, my frame width left will equal my GS frame width, 50. This statement here in brackets will return is a logic test, and it will return either 0 if it's false or 1 if it's true. A value multiplied by 0 is 0, value multiplied by 1 is the value. So we add either 0 to the frame width or another frame width. So this statement here is the same as that statement there. So let's set our frame width left. Now I can change this to be smaller than and tighten up my code a little bit. Let's just check to see it still works. Yep. Good. Do the same for the right. I also actually need to put my define fill up the top here as well before I use it. So now we've got a frame width left and a frame width right that will change depending on whether that step here is going through the cut plane. So now I can use these. Left is this side. So we want to go minus A2. So it's a bit clunky, but we minus A2 to the opening, we plus our frame width, and then we minus whether it's a normal frame width or an extended frame width. It's a bit clunky, but saves me having to add another conditional statement or another variable up here. I've only done it to the 1. Excellent, so that's working. Now I've added it to all positions, all coordinate points. We can see that that is working. Good. Now let's add back in our frame fill. The 2 doesn't have to go in the middle here. It can go on the end, just as long as it all adds up to a number. But it makes sense and it keeps your code neat and tidy and understandable. All right, we'll add our centerpieces as well. That will be a door leaf though. I've just created a call to a leaf subroutine here, and this is where we'll draw our leaf. Let's take the axes out of my frame, put it in my leaf. It's in the same place. But now we know exactly where it is when we call this subroutine. And we also need an empty fill. Now we have defined it because we call our frame first, but if we rearrange this, then this will get lost. So what I'll do is I'll create a subroutine where we can set these attributes that we are going to be using throughout our script. Now I can use them again down here. Even though they've already been set in a previous subroutine, it's good to keep things contained so they're understandable and they don't get messed up if you shuffle things around. We'll draw our frames first. If we check out our 3D script, I'm using the same building material for the frame as I am for the leaf. You can choose to add a separate parameter to deal with that, but for this script, they are the same. So what I can do then is also take this request up into my set attributes so that I can use this down in my leaf subroutine. And what we learned from our previous frame exercise is that we draw our outline first and then we draw our cut styles on top of that so that they come up correctly in the display order. Now, as I've mentioned, you can deal with this display order with the draw index command, but it's just simpler and easier if you deal with it in order of execution. So what have we got? We have a poly2 underscore with 4 coordinates. We want to draw a line, draw a fill, close an open polygon. We want to start at this point here, which is minus a divided by 2 plus GS frame width. 0 in the Y. 1 means it'll draw the next contour. The next point will be this point here, but it'll be minus, what is it? GS leaf thick. Then it's over to the positive side and back up to this point, drawing our rectangle. Righto, there it is. Let's just make it a little bit thinner. Just make it stand out a little bit more. Draw our styles. We've set our pen, we've set our fill. And this time, the styles will be exactly the same, one side to the other. So this time I will do a loop, setting a made-up variable, telling it its range. It's going to start at 1, and it will go to 2. Default increments are 1, and then it will execute whatever between these two statements, and then pop around here, increment my I, and go again. Make sure that you haven't used this somewhere else because you can get into an infinite loop if you use the same counter inside another loop. It never gets to the end. What do we want to do? We want to add across to here, draw our frame, delete, come back to here, and in order to come back to here, we will mirror our transformations, scale them by a -1, and then do the same thing again. So we'll go add to a divided by 2, which will get us to this point, minus GS frame width, nothing in the Y. We want our poly2 statement with 4 coordinates. We're drawing this bit here, start at 0, 0, come back, and that will draw our little rectangle. Then we want to delete our transformation within our loop, So we've come across to here, drawn our rectangle. We want to delete it. We want to mirror, which is a mul x, multiply, -1. We'll mirror it, scale it the other way. Then we come back up to the top and go again. And so at the end of it, we will have one transformation, but that gets deleted. One transformation, so that carries over 1, 2. So we'll delete 2 transformations. Oops, it's not mul x. Mul x is a 3D command. It's mul2, an x and a y. That's better. Right. So something's wrong. What's wrong? I need to use a poly 2B instead of a poly 2, because a poly 2B has finer control over your fills. It's a good thing to note. That's better. Same fills now. We've got our centerpiece and we've got our glass to add yet. We have a look at our glazing bars. Now in my GDL object, I've made my glazing bars the same thickness as my leaf. Save me having to create another parameter to set, but it would be straightforward enough to do that, to create another parameter to set your glazing bar thickness and your glazing bar width. And I've just done it all the same for simplicity's sake. But these glazing bars are also symmetrical around the center of the leaf. So I can fold this operation into the same loop that's drawing these leaf styles. So we'll go styles. What we need to know is our glazing bar diameter. We've added across to here and drawn that. We'll delete that add here. Make that add part of this style. Now that's just a comment for me, so I know what's going on where. And what we'll do is we'll add half our glazing bar diameter. Now strictly speaking, that's not correct, because if our cut plane is not cutting through this center glazing bar, then it'll be cutting up here somewhere and it won't be a true diameter. If it is a true diameter, then it will just be a completely cut glazing bar all the way across, here to here, here to here. But for the sake of making it look the way I want it to look, this is what we'll do. And I can do that with GDL. Just copy down our previous poly 2 statement that we've worked out. We'll change our coordinates. Now in this case, I have used exactly the same coordinates because my glazing bars uses the leaf width and thickness parameters. It's exactly the same coordinates. There they are. So what that means I can do is I can put these coordinates into the buffer and only have to put them in once in my script. So I've put them into memory, and now down here I will say use number of stored parameters, and instead of 4 coordinate lines it will be number of stored parameters divided by 1, 2, 3. And I want to use them and not get them both times because I've only entered them once up here outside the loop. So I come through and use them. Now when I drop out of the loop, I want to get rid of them. I'll go if NSP, so if there's anything stored in the buffer, if NSP is greater than 0, then trash, that's just a made up variable, equals. So max will find the maximum value between 0 and get NSP, and the command get NSP will clear the buffer. So this is a handy piece of code to clear your buffer. Save it. There we go. We'll wrap this one up there. If you watched to the end, good on you. You'll know more now than you did at the beginning. Well done you. Next up, we tackle some more 2D problems, which include setting the opening angle of your leaf, getting the swing arc settings from the MVO, and setting the origin of your fill, which is actually harder than you might think. I'll see you there.